volume is easier than surface area, which is good. Volume is the amount of space something takes up. So like how much water you could pour into a container. So how much space something takes up. So similar letters in our formula. Capital B still is area of the base. So if your base is a circle, that's the area of a circle. If your base is a triangle, that's the area of a triangle. H is still height. That's the distance between your bases in a prism. And then R is radius. So we're just going to practice again real quick finding capital B with the base shape. So for example, on the cylinder, what is the base shape of a cylinder? A circle. Yeah. So the base shape of a cylinder is a circle. What is the base shape of a rectangular prism?
Any of them.
Yeah, any of them. Yeah, rectangular prism. Any of the sides could be bases. So it's going to be a rectangle. Remember, your bases just have to be parallel to each other. So I picked the bottom. You could have picked the sides because the sides are also parallel to each other, or the front and the back. Now here's a tricky one. For the triangular prism, which shape is the base? The triangles. Very good. Because the triangles are the parts that are parallel to each other. Yeah, it's not the rectangle. It is the triangle. That's definitely the most missed pieces on those. But good. You guys know it. Okay, so we're going to do the volume of some basic solids. So first up we have our triangular prism. So our formula for all prisms is that volume equals capital B base times height. So first, I'm going to kind of come over to the side and find what is the area of my base. So we just said that the base shape of a triangular prism is the triangle. So we need to find the area of a triangle. So what's the formula for area of a triangle? Yeah, 1/2 base times height, or base times height divided by 2. Very good. And remember, that's on your formula chart. Make sure you know where to find it in case you need it on a quiz. So for our triangle, the base and the height of the triangle, is that going to be the 6, 8, 10? Which one of those do we use? The 6 and 8, because remember, base and height are perpendicular. Yeah. Remember my song? Yeah? Okay, so we're using 6 and 8 because that's the base and the height because they are perpendicular to each other. We know that because of that little right angle. So multiply those things together, and we get 24 for the capital B. So back up to our original formula, volume equals capital B is 24. H is the distance between the bases. So the distance between the bases is 14. So 24 times 14 gives us 336 units cubed. So volume is units cubed because it's three-dimensional. So volume is always going to be units cubed. All right. You guys want to go ahead and try the rectangular prism? I feel like you can do it. Try the rectangular prism and we'll check it together in a minute. So on this one, when you take a calculator like this, what it does is it divides by 4 squares. So if you want to divide by 4 squared pi, you have to use it.
Yeah.
Right, because your calculator sees it base divide by 4 squared. It does that, and it sees yeah, so either use your principal or you can do it off the right answer and do the addition. Yeah.
Oh,
So if I do a fraction, I'll have to focus.
Right. Okay. Yeah. So maybe do that.
Oh.
Yeah. Yeah. Thank you. Mm-hmm.
I'm not gonna give you an answer now.
What did you get? All right, look up and check your work.
Oh, I wasn't done. I was saying, with that, is it just that and that?
Yeah.
Is that, what is that?
Well, so this is, if I color in the bottom of that my base, then that means this is gonna be your
Plug in
If
numbers.
it was
You got it?
That's right.
You did put unit square.
All right, so for this one, your base shape was a rectangle. So I let the bottom be the rectangle that's going to be my base. So 15 times 6, because for area of a rectangle, we just do length times width. So that's 90 times the distance between the bases that I chose. The distance between those two bases is 9, so I get 810 units cubed. You guys okay on that one? Okay. All right, volume of a cylinder. Volume formula for a cylinder is pi r squared times height. So if we plug in, we have pi, r is for radius, that's going to be 3 squared. Height, again, is the distance between our bases, so that's going to be 10. So type it onto your calculator, pi times 3 squared times 10, and we get 282.7 units cubed. Yeah.
For the prism one, does it matter if you do different bases?
Good question. I'll do a little example. Which side did you do as a base? Did you pick a different one?
The other base?
Did you do like the left side?
Yeah.
Okay, so pretend on the prism you had picked the left side to be your base. The dimensions of that side would be 9 and 6. So your capital B would be 9 times 6, which would be 54. And then the distance between your bases would be the 15. So you would do 54 times 15, and that is still 810. So no, it doesn't matter which side you let be the base on a rectangular prism. All right, on to the back side. Okay, on the back. We are going to look at pyramids and cones. So for the one on the left, we have a triangular prism. What is the base shape of that one? Not prism, pyramid. Yep, a triangle. Next, we have a rectangular pyramid. What's the base shape of that one?
Rectangle.
A rectangle. And next, we have a cone. What's the base shape of a cone? A circle. And just as a reminder, for sphere, R is radius. Also, the height of pyramids and cones start at the vertex and they drop straight down to the center of your base. So when we're doing volume for pyramids and cones, we're not looking at slant height. We're looking at the height from the vertex to the base. Guys, shh. Okay, we're going to try a working backwards one. So for this one, a sphere has a volume of 1436 cubic millimeters. What is the length of the radius? So whenever you're working backwards, we can start with the volume formula for what we have. So volume of a sphere is 4/3 pi r cubed. After we start with the formula for what we have, we plug in what we know. So the volume is 1436 equals 4/3 pi r cubed. Now we want to get the r by itself. The 4/3 and the pi are being multiplied by r cubed. So how do we undo multiplication? Division. So we're going to be dividing. So I'm going to divide by 4/3 pi on both sides. Now I'm going to show you this next part underneath my document camera because it's important how you type this into your calculator. So I'll show you a couple examples of how you could do it. Let's see. There we go. Okay, so let's see. So I have, oops, you can't see that, it's too small. There we go. So if we have 1436, I'm first going to show you how not to do it. If you do divide by 4/3 and then pi, if you do this way, what your calculator does is it sees 1436, it divides by 4/3, and then it multiplies by pi. So we don't want it to multiply by pi. Pi is being divided also. So you've got to use your parentheses so that it divides by everything. So for example, I can do 1436 divide by, open my parentheses, do my alpha y equals enter to get my fraction, so 4/3, and then type in pi. Do you see how those answers are really different? Yeah.
Can we also do like the 1,436 divided by, and then do 4 divided by 3 times pi, like in the parentheses, or do we have to make it into like the fraction in our calculator?
Oh, are you saying like this?
I mean, I don't know, there's too many parentheses.
Yeah. Yeah, you can do that. That would be the same as if you did.
Okay, that's what I was wondering.
Yeah.
'Cause I didn't remember how to make it like into the fraction of the fraction.
Yeah. Yeah, if you want to make a fraction in your calculator, the calculator is, you click the alpha button. So alpha is the green one. You click y equals, that's on the top left by your screen. And then you click enter, and that's going to pop open a fraction. So you can do that, or you can do this up here also. So anyways, use your parentheses when you're dividing by more than one thing is the idea. Okay, so once we get there, once we divide by our 4/3 pi, we end up with 0.8 equals radius cubed. Okay, so if this was radius squared, we would take the square root of both sides to undo the square. How can we undo a cube? Anybody remember? We can do a cube root. Yeah, so there's a square root undo squares, cube roots undo cubes. So a cube root looks like this. So it looks like a square root, but then there's a little 3 inside right there to say, hey, this is a cube root, not a square root. So we cube root to undo a cube. And I'll show you how you cube root in your calculator. Okay, so in your calculator, to cube root, you're going to go to the math button. So math is on the left underneath the green one. And cube root is option number 4. So math and then option number 4 is your cube root. And then remember, you can arrow up to highlight previous values and hit enter, and it's going to pop it into your cube root. So the cube root would be 6.999, really if you rounded. So that's going to really round to 7. So our radius is 7 millimeters. So if you want to write that down in your notes, you go to math and then option number 4 for your cube root. All right, okay. I'll do the cone with you guys. So if we find the volume of the cone, Alright. Okay, so volume of a cone is volume equals 1/3 capital B base times height. The base shape of the cone is the circle. So off to the side, I'm going to do capital B base equals pi r squared because my base shape is a circle, so I need to find the area of a circle. So plugging in, I get pi times 8 squared. That's going to be my capital B. And then the height in our original formula is going to be, is that 15 or 17? Yeah, it's 15. Remember, 17 would be the slant height. 15 is the regular height. So our whole formula is volume equals 1/3 times pi 8 squared for capital B times 15. You guys can go ahead and try the pyramid and the sphere when you're ready, and we'll check it together. Okay, so for a pyramid, the base is like what everything else is connected to. It's on the bottom, to the square. Mm-hmm.
Wait, but I thought you said they're the ones that are parallel.
Okay, true, but that's for a prism because those triangles aren't parallel because they connect, they intersect. Yeah, so they're not parallel.
The area of the rectangle.
Mm-hmm. Hang on just a second.
That's why I'm just like, I'm just like this square.